A new white paper from Intertech Development Company explains the concept of test-centric assembly, which is a best practice approach for any test-intensive assembly operation and incorporates fail-safe leak testing. This white paper is for mechanical engineers, quality engineers, and management. The goal of test-centric assembly is perfection. The result is improved throughput, yield, system uptime, and time to market. Founded in 1973, Intertech Development Company is a world leader in test-centric assembly, specializing in automated leak and functional testing, with 7 patented mass flow and hydraulic technologies, as well as proven expertise in helium mass spectrometry. Test-centric assembly is not a product, it is a process, and it requires that test engineers be granted equal place on the teams that design and engineer production and assembly systems. If you lose control of quality in a production process, the consequences can include the direct costs of rework, reinspection, and retesting of rejected shipments, if the shipment was not scrapped. There can be product recalls, and this can drive a manufacturer into bankruptcy if you're not careful. There are myriad negative consequences of quality failure, such as the permanent damage to corporate and personal reputations, or the need to completely re-engineer a production system. And all of this is entirely avoidable with test-centric assembly used as a strategy for your company. Test-centric assembly asks you to consider testing up front in the design of the assembly and production process. The goal of perfection is a disruptive concept. It requires commitment of all teams involved in the production process. For reliable test results, the entire system needs to be treated as a gauge to have confidence in test results. Return on investment for test-centric assembly is found in many ways. It has a ripple effect on the entire manufacturing process. Rework is cut by 20% or more, partly because good parts are not misclassified as bad, and partly because problems are identified earlier and fixed sooner. Perfection is attained in the details of gauge repeatability and reproducibility, creating reliable, useful feedback for more efficiency. Process improvements, especially with mass flow leak testing, create faster processing, which requires fewer test stations. This can lead to capital expenditure savings of 50% or more. Test-centric assembly is insurance against blown budgets and protects your reputation. Intertech's white paper explains how to start dry. In other words, dry air is the testing medium of choice in everything from catheters and assisted breathing devices to heat transfer units, solenoid valves, and hydraulic systems. Air is the preferred test medium because in most cases it is more accurate, faster, and less mess. In its white paper, Intertech compares mass flow and pressure decay leak testing. Intertech has patented mass flow systems that actually measure leak flow during the stabilization process. When pressure decay systems start testing, mass flow is already finished. This is a huge time savings advantage. It can save up to 30%, and the larger the part, more volume, the greater the advantage for mass flow techniques. Intertech's white paper addresses many issues, including the importance of precision fixtures. Production techniques for test systems simply won't do. Automation engineers are experts at creating fixtures for rapid assembly throughput, but may be surprised to learn their techniques are detrimental to fail-safe leak testing. For example, when automatically driving screws through an assembly, it is normally best to have a fixture with some float around the holes, so screws can center themselves. However, this can lead to seal creep on a test fixture. Testing creates wear, so the finish on a test fixture may need to be superior to those for assembly. Clamping pressure can mask a leak. Sometimes a part must be tested in the same orientation it will assume in the field. Automotive valves and respirator components for assisted breathing devices often have this requirement. For all these reasons, and to avoid re-engineering costs later, engineers are well advised to consult with test equipment suppliers on fixture design before production plans are frozen. As Intertech Development Company explains, test-centric assembly is the culmination of best practices in leak testing and the latest technology to ensure optimized throughput without adding unnecessary production cost. Test-centric assembly, which embraces fail-safe leak testing, is a major insurance policy on the reputations of companies and products. Engineers with leak testing expertise are vital to system design of any production line where testing is essential to the production process. With test-centric assembly, management is empowered to be proactive and not forced, so to speak, to react to relentless demand for heightened tolerances and traceability. When a machine builder offers to provide testing, make sure they understand how to detect leaks and improve the process with test-centric assembly. This has been a presentation about the Intertech Development Company White Paper on Test-Centric Assembly. Thank you.